Law of conservation of energy. Basically, what this law states is when an energy gets transformed into another form of energy, we have just noticed in the previous section, the transformation of energy from one form of energy to another form of energy. So when this happens, the total amount of energy remains constant. So that is what this law says. The energy is neither created nor destroyed. So whenever energy changes from one form to another, the total amount of energy remains constant. That's what this law states. It means there is no loss or no gain of energy. In other words, we can define another definition for this law is energy can neither be created nor destroyed. So the energy is always constant. See, for example, if we take a bulb. In a bulb, electric bulb, if you say, in an electric bulb, what happens? The electric energy gets converted into light energy. But in the process of this conversion, some energy is wasted also. Some electric energy goes in the form of heat energy because the bulb gets heated. So some electric energy, EE, electric energy, is wasted in the form of heat. But ultimately, this light energy plus the heat energy is the electric energy. That means the total energy of the system remains constant. So in this case, it becomes electric energy. In this case, it is nothing but light energy plus heat energy. So the energy is not wasted. The total energy in the system remains constant. So let's understand this in a better way by seeing a freely falling body example. So what basically now we say through the law of conservation of energy that the total energy of the system remains the same. So total energy of this system of electrical thing remains the same. So let us see the freely falling body example. Stone or ball, whatever it is, of mass m, which has been thrown up to a height h. This is mass m and the height is h. Now what happens? As the ball reaches the height h, what is the potential energy? The potential energy of the ball is mgh. So we'll say this is a ball. It's a ball of mass m. Now potential energy is mgh. As the ball, now what we do is we'll make this ball fall down. Now the ball is falling down. Let's say the ball is here. As the ball is falling down, what happens to the energy? The potential energy which is possessed by the ball at this height is mgh. Now this potential energy, as per the equation, the h reduces. So when the h is reducing as it is falling down, but the potential energy also reduces. So as the ball falls down, what happens? Height reduces, hence potential energy also reduces. But what happens in this case? When it is falling down at that time, the potential energy which is possessed at the height of h gets gradually converted into kinetic energy. Only when it is getting converted into the form of kinetic energy, the ball can actually move. So it is getting converted into kinetic energy. So kinetic energy is defined as half mv square. So it is depending on the velocity. So what happens basically, the kinetic energy starts increasing as v is increasing. And potential energy is decreasing as h is decreasing. So as the ball falls down, the velocity v starts increasing, so kinetic energy starts increasing because kinetic energy is half mv square. So having understood this factor of how the energy gets transformed from one form to another and how as one is increasing, the other is decreasing. So by which we can state that gradually the potential energy gets converted into kinetic energy. So at any point of time, the sum of potential energy and kinetic energy is the same at every point during its fall. Since the potential energy is gradually getting converted into kinetic energy, as the potential energy is decreasing, kinetic energy is increasing. So the sum of these two will remain same at any point during the fall. So we said that potential energy converted to an equal amount of kinetic energy when it is at the bottom. So when the ball reaches the ground, what happens on reaching the ground? The potential energy is 0. Why? Because H is 0. So potential energy is 0 and kinetic energy is half mv square. So at the height h, potential energy is maximum and kinetic energy is 0. When it reaches the ground, potential energy is 0 as h is 0 and kinetic energy is half mv square. So the entire potential energy got converted to kinetic energy. So we say the potential energy converted to an equal amount of kinetic energy. At the end of it, we say that the total energy of the system remains constant. Therefore, we say mgh, which is potential energy, plus half mv square, which is kinetic energy, remains constant. Yes, we do say when a ball hits the ground, there may be some sound. Part of this kinetic energy got converted into sound. And there may be a heat also that is produced. Slightly the ball may get heated. But in spite of all that, the total kinetic energy now is kinetic energy possessed by the ball and the sound and the heat energy. So total energy in the system remains the same. So in this freely falling body example, we arrive at a conclusion: potential energy plus kinetic energy is constant at any point during the fall.